Hey guys, hello everyone, welcome back to our channel. So today we are going to learn a problem on mathematical induction. So our problem for today is prove that 1 plus 2 plus 3 plus so on till n is equal to n into n plus 1 by 2 by the principle of mathematical induction. So it's a chapter from Intermaths, and the concept for mathematical induction says that we have to prove a given statement for suppose a function in n should be true for n equal to 1. This is the case 1. Okay. The case 2 says p of n is equal to true for n is equals to k, and the case 3 is p of n is equals to true for n is equal to k plus 1. Okay, these are the three cases that we have to prove, and we shall be proving it we shall be good to prove it via mathematical induction. Okay, as I said, if we prove the three cases, we shall be good to prove for mathematical induction principle for this sum. So first case for us is to prove p of n is true for n is equals to 1. That means if you substitute 1 in the place of n, you should be getting LHS is equal to RHS. So if I put RHS is equals to n into n plus 1 by 2. So it is 1 into 1 plus 1 by 2, 1 into 2 by 2, which is equals to 1. So our LHS is equal to RHS. So our function, this function which is denoted by p of n, is true for n is equals to n is equals to 1. So we had proved the first case. Let's move on to the next. So our case 2 says we need to prove p of n is true for n is equals to k. That means you will have to substitute k instead of n. So it will be 1 plus 2 plus 3 plus so on till k, and then this will become k into k plus 1 by 2. That's it for case 2. Our case 3 would be proving it for k plus 1th term. So what I'll basically do is add k plus 1th term on both sides. So this side it will become p of k plus 1 is equals to 1 plus 2 plus 3 plus k plus 1. I'm adding k plus 1th term. So our right side term, how should we write that? It is k and then k plus 1, as I wrote n and then n plus 1. Here also I'll add, this is the k term plus add k plus 1. So I'll take k plus 1 outside as common for both the terms, and it will become k plus 1 into k by 2 plus 1. Furthermore, if I write, it will become k plus 2 by 2. Okay, after this step, we can write this as k plus 1 into k plus 1 plus 1 by 2, which means k into, this is the k plus 1 by 2. That is k into k plus 1 by 2. So our k for this case is k plus 1, right? So we have derived at the solution wherein we prove that it is in the form k into k plus 1 by 2. So hence p of n is also true for n is equal to k plus 1. Therefore, by the principle of mathematical induction, this problem statement holds true for all the natural numbers. Okay, then that's it for today's video. Meet you in the next video in some time with a new problem from a new chapter. Till then, keep learning, keep enjoying.